In my previous video, I discussed about voltage across series resistance. So this time, we are going to discuss about current through parallel resistance. So we have this problem. Resistors are in parallel across a battery of 12 volts. The resistance are R1 22 ohms, R2 47 ohms, R3 68 ohms. These three resistors carry a current I1, I2, I3 respectively. What is the current I3 through resistor R3? What is the total current drawn by the circuit? So we have two question. We need to find what is the current flowing in R3 resistor. So we need to find R3. Okay, and also the total current of this circuit. We have a theory on parallel circuit that the voltage is one parallel circuit, parallel loads is one. The voltage across all components are the same because the components directly connected at the same point, at the same 2 points in the circuit. So let's say we will extend this one. Let's say we have a voltmeter or digital voltmeter here connected. Show me this one. So if we this is the B out. So the voltage appear here is just the same as the supply voltage. So any point across the components, the output voltage is equal as the input voltage in parallel connection. Okay, so back on the question of what is the current value of R3. So this is R3, this is R3. So simply because we can also apply the Ohm's law here, directly substituting the value. So Ohm's law, by Ohm's law, so we have V or E, it's just the same, equals to current times R. So we can now get the value of I3. This one, I3. I3 is the current flowing on R3 resistor, which is 68 ohms. So I3 equals E over Okay, R3. So we have 12 volts over 60 ohms. So we have what, 0.18 or 180 milliamps. So this is the value of I3, this one, the current across R3 resistor. Okay, so we have now a value of 180 milliamperes for the current flowing at R3 resistors. So the second question is total current IT is equals to I1 plus I2 plus I3. So this is for total current. By the way, in a parallel circuit, I mentioned earlier that the voltage are equal at any points across the components, but the computation of the current is we need to add up each component, the current of each component. We need to add up to get the total current. So we have two method of solving this total current. So this is the first method. So first method, like this one. So we need to add up each current of these three resistors. So just like in how we compute the current I3. So just a similar approach, but we need to calculate one by one. Okay, so we have now the current of each resistor. So for R1 we have this one, 12 volts supply over 22 ohms. So we have 0.5445 ampere. And for current 2, so 12 volts supply and then 47 ohms load resistance. So we have 2553 ampere. For current 3, so 12 volts over 68 ohms. So we have a 0.1765 ampere. So I just round off this one. So to get the total current using first method, so I1 plus I2 plus I3. So just substitute the value. I1 is 0.54 plus 0.25 3 plus C 0.18. So we have what, 0.98 ampere or 980 milliamp. So this is now the total current. Okay. The other method in solving the total current is by computing the total resistance. Okay, so second method, so second method, so the total resistance of three resistors in parallel is R1, R2, R3 over R1, R2 plus R2, R3 plus R1, R3. Okay. By the way, this formula is already I already discussed this on my previous video. This a shortcut formula. So we need to calculate the total resistance of this circuit. This for another method in solving the total current. Okay, so we have now a value of the total resistance on using second method. So this time we can now get the total current of the circuit. So therefore the total current is equal to B supply or E over RT. So RB is 12 volts, our RT is 12.27 ohms, which gave us approximately 0.098 or 980 milliamps. Okay, so we just arrived the same answer, 980 milliamps for the total current drawn by the circuit. Okay, thanks.